Lesson 3-2, solving roots of polynomials using factoring. Well, first of all, let's review the different terminology that we have used when it comes to x-intercepts. So right here at the beginning, please get acquainted with all usage of these four words: root, x-intercept, solution, zeros. They will be used interchangeably consistently, okay? I will say root and x-intercept and zero seems to be used a lot more than solution, but all of them are synonyms. So what is a root? The root is the x value where the y value will always equal 0. So please, 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 this algebraic definition here is something that you definitely need to make sure you know. This is the algebraic definition of an x-intercept, okay? So whenever we're looking for an x-intercept, the coordinates will look like this: x comma 0, where the y value is always a 0, okay? Graphically, this is the point where the graph crosses the x-axis. So as far as the definition for graphs, we will say that the location where the x-axis, where the point on the x-axis crosses, that is known as the x-intercept. So in this image down here below, notice we have 1, 2, 3 x-intercepts, and you can also see that the coordinates are given, and notice that every single time the y value is a 0. On Delta Math, they are going to want you to just write x equals whatever the number is, okay? So sometimes we can just write it like this. We don't necessarily have to write the coordinates, the x and y coordinates of each point. So we can find information about the number of real zeros of a polynomial by looking at a graph, and conversely, we can also tell how many times the graph is going to touch or cross the x-axis by looking at the zeros of these polynomials. So when I look at this x-intercept, this 0, I am able to tell how many times this 0 has occurred, okay? And that is based on the shape of the graph at that x-intercept. So what I'm going to have you do is skip this section here of factor theorem, and let's go down here to where we're talking about multiplicity. Okay, so read along with me on this paragraph. A 0 has a multiplicity, which refers to the number of times that its associated factor appears in the polynomial. The multiplicity of each 0 is the number of times that its corresponding factor appears in the polynomial. So please notice that the multiplicities will be the powers of your factors, okay? They will be the powers of your factors. Now, what does this all mean in the context of this problem? Okay, so for instance, in this picture right here, notice that they're giving us a picture of a curve on 3 different graphs, and they're showing us where it's crossing the x-axis. So this here is my x-intercept, or my root, however you want to call it. I'll call this one a root just to make it a point. X-intercept, root, solution. What was the other one? I already forgot what the other one was. Oh my goodness. What is it? X-intercept 0. So 0. I'm going to use the 3 popular ones. So whatever word you want to use, those are your x-intercepts. Now, this graph right now is going through the origin. These are just examples. Your roots are not always going to be at 0, 0. Okay? Now, if your piece of your graph crosses through the x-axis from one side to the other, okay? So it just crosses through. If your graph crosses through, let me write graph. Graph crosses through, and it mimics a line and looks like a line, okay, you are going to tell me that it has a multiplicity of 1. So I'm going to actually not use p equals 1, I'm going to use m. it has a multiplicity of 1, okay? Now, if your curve hits the x-intercept and bounces off like it did here, so notice this curve comes down, it hits the x-intercepts and ricochets up, okay? And it has a parabolic shape to it, okay? So it touches the x-intercept at a curve, like a parabola, okay? Like a parabola. That means the multiplicity is going to be a 2, okay? Think of it. A line, think of your section 3.1. A line has a power of 1. A parabola has a power of 2. Now, how about this one? This one looks like a cubic graph. This is a mistake, actually. This one will have a multiplicity of 3. So if your curve crosses through your x-intercept in a wave fashion, okay, in some sort of wave fashion, then it will have a multiplicity of 3. So that means the factors of this x-intercept occurred only once. The factors of this second x-intercept occurred twice, and the factors here occurred 3 times. So if you look upstairs at this other picture that we have upstairs, this first one at x equals -2, the multiplicity is going to be a 2 because it has a parabola shape, okay? Over here, the multiplicity was only a 1 because it went right straight through the x-axis, as well as this one did. So that's how you determine multiplicities, okay? So now we're going to move on, and we're going to talk about the factor theorem. Now, the factor theorem says if we know what our 0 is, or what our x-intercept is, you can rewrite it as a factor. So for instance, I'm going to use r as my x-intercept, right? If r is a 0 of p of x, so let's say my 0 is 4, okay? Let's say the graph crosses at 4. Then x minus 4 will be my factor. So this is how you tell me that is what you know your x-intercept is, but this is the factor of the x-intercept. So for instance, if r is positive 8, the factor is going to be x minus 8. If r is -3, then the factor is going to be x plus 3, and so forth. I'll do it one more time. If r is a 7, okay, it will be x minus 7. All right, so that's how you write the factor. So option number 2 is just telling you to go backwards. So you're basically going backwards. They can give you a factor and you can come up with the root. So why is that important? So if you look here at this example right here, they're giving us a polynomial that's in factored form. So notice this is all in factored form. It is not in standard form. Okay, this is in factored form. So if you're asking yourself, well, what does standard form looks like? So I'm going to scroll down here. Standard form looks like this one right here. I'm going to square it off down here. Okay, do you see the 2x cubed minus 3x squared plus 18x minus 27? That has no parentheses around it. Okay, so let's go back here. So where am I? Right here, the factored form. So factored form has parentheses. It's a product of factors. I want us to state the degree, list the zeros, and their multiplicities. The degree is found whenever it is a factored form, okay? If it's factored, the degree is found by adding the powers of the factors. Add the powers of your factors. Every factor has an exponent. So the power of my 2x factor is an invisible 1. The power of my x minus 1 factor is a 2. The power of my x plus 3 is a 1. And the power of x minus 4 is a 3. So in this case, the degree of my polynomial is going to be a 7. Okay, that's the highest exponent. If I multiplied this factored form out and converted it into a standard form, the highest term, the leading term, will be an x to the 7th power. The next thing you're going to do is list the zeros. This is what we're going to do next. So we're going to use the factor theorem. The factor theorem told us that if we know the factor, we can find the zeros. So I'm going to put the first factor, and I'm going to set it equal to 0 to solve for my x-intercept. So if I divide by 2 on both sides, my first 0 is a 0, because 0 divided by 2 is 0. Let's do it again. My next factor is x minus 1. Set it equal to 0. I'm going to solve. So I have to add 1 to both sides to get x by itself. X equals 1. And you keep doing that for every single one of the factors that you have. Subtract 3 on both sides. This is my third 0. And my last one. Set it equal to 0. Add 4 to both sides. And x equals 4. So those are the zeros of my polynomials. That's where the graph, if I were to graph this factored form of a polynomial, this is where the graph would cross the x-axis. To determine the multiplicities, okay, the multiplicity of each factor is going to be the power of the factor, okay? So x equals 0 was found from the 2x factor. And 2x had a power of 1. So let me use a different color here. That means that x equals 0 has a multiplicity of 1. The x minus 1 gave me the x equals 1. That had a power of 2, so the multiplicity of that has a 2. X plus 3 gave me x equals negative 3. That has a multiplicity of 1. And the 4 had a multiplicity of 3. So all this is saying is, if I were to have graphed this polynomial, at x equals 0, the line is going to go straight through. At x equals 1, there's going to be a bounce. At x equals negative 3, the line is going to go straight through. And at x equals 4, there's going to be a curve. That's all that means graphically. So you will be graphing that in the future. Okay? So we're done with that problem. Okay? There will be times, though, that a polynomial will not be given to us in factored form, but rather in standard form. Okay, so let's look back at some factoring techniques to see what we would do if it's not given to us in factored form. Now, one thing that I want to make sure that you pay close attention to, because this is so important, especially when you're factoring in your Delta Math homework, okay? Please, whenever you are required to factor any number of terms, you need to make sure that the first thing you do is find the greatest common factor. That's the first thing you'll always do, okay? Before anything, please, please, please find the greatest common factor. Do that first before diving into anything. What does the greatest common factor look like? Well, here's a very simple, quick example. 4x2 minus 12x. The greatest common factor between 4 and 12, that would be a 4. And x squared and x, well, I have an x squared, that means x times x, and then the next term I have an x. Well, they only have x to the first power that match. So 4x is the only thing that they match, okay? So What does that mean? So when I factor 4x squared minus 12x, I'm going to take out the 4x, and now I divide this by 4x, and I divide this by 4x, and whatever the results are, I put it inside the parentheses. So 4x squared divided by 4x is going to be an x. 12x divided by 4x is going to be a 3. So now that's my factored form of g of x. So if I needed to find my zeros, I could set this equal to 0, and I could solve. 4x equals 0. If I divide by 4 on both sides, x is going to be 0. So that's the first x-intercept. And then this one is pretty straightforward. X is just going to be a 3. Okay? So if I had to give the multiplicities, again, let's write the multiplicities here for practice. This one would have a multiplicity of 1 because this has an invisible 1 right here. And this also would have a multiplicity of 1 because it has an invisible 1 right there. If I wanted to figure out the degree of this problem, I would just add the multiplicities, 1 plus 1, or 2. Okay? All right, the next type of factoring that I want you to remember is difference of squares. So here's difference of squares. When you have two perfect squares, you will always factor it by writing two factors and taking the square root of the a squared and the b squared. Okay, so a squared minus b squared can be rewritten in factored form as a minus b or a plus b times a minus b. It actually doesn't matter how you write it. And the way you get this a and b is, in essence, what you're doing is you kind of square rooting this perfect squares. That's what you're doing. So here's what I mean by that. Let me take away those square rooting because that's just conceptually what you're doing. Okay, so here's 25x squared minus 100. Now, you're going to be tempted to want to automatically do the difference of squares, but what you need to do first is what I've always told you. Find the GCF first. So what is the GCF of that problem? Think about it. Okay, the GCF of that problem is 25. Okay, both this and this is divisible by 25. They don't share any x's, so 25 is the only thing we will pull out. So 25. Now, I'm going to move this here so I can visibly write what I'm going to do. Open parentheses. So I have to divide this by 25 and divide this by 25 to figure out what's the remaining factor. Well, 25x squared divided by 25 is x squared. 100 divided by 25 is a negative 4. Now, x squared minus 4. X squared minus 4 is the same thing as saying x squared minus 2 to the second power. So, how am I writing the factored form? Well, whoops. What did I do here? I accidentally made this too small. Okay, so there we go. So x squared minus 2 squared is, if I square root this and this, in essence, the square root and the square disappear. So I have an x, and the square and the square root disappear, and I'm left with a positive 2 and a minus 2. Okay, so there is the factored part of x squared minus 4. So 25 comes down, and x squared minus 4 breaks down as x plus 2 times x minus 2. Okay? And again, if you applied the zero product property, you would get a negative 2 as a 0. You get an x equals positive 2 as a 0. And those would be your x-intercepts. Factoring trinomials when a is equal to 1. So what do we do here? So trinomials means 3 terms, right? Now, sometimes our 3 terms we'll have an a value that's 1, and sometimes we'll have an a value that's not 1. So what do I mean by a value? So let's talk about that. So let us write it over here on the side. So if I have a function that's a trinomial that is written in this format, ax squared plus bx plus c. The a is the number in front of x squared, the b is the number in front of x, and the c is the constant, okay? So if you look at this particular problem that we're getting ready to work on, let us find what a, b, and c is equal. Well, the number in front of x squared is an invisible 1. The number in front of x is a negative 8. And the constant is your positive 15. Okay, so that's the first thing you will do if you have to factor a trinomial. Now, what I'm trying to do is figure out how to rewrite f of x in standard form. In factored form. So what times what gives me x squared minus 8x plus 15. It's reverse distribution in essence, okay? So here is the thought process, okay? What times what will give me the c value, and the c value for us is 15, that at the same time, when you add, would give me my b value, and the b value is the middle term, negative 8. So take a second. What times what two numbers multiply to be 15 that at the same time give me negative 8? So you may have guessed negative 3 and negative 5, or negative 5 and negative 3. It doesn't matter the order. Okay? So once you've figured out those two numbers, you actually are done. So what you will do, you can write an x here and an x here because we know x times x is x squared. And then the two numbers that you just found, you will write it next to the first x, next to the second x. And just to prove to you that this works, here's me showing you through doing a check. If I do x times x, that's x squared. X times negative 5 is negative 5x. Negative 3 times x is a negative 3x, and negative 3 times negative 5 is a positive 15. If I combine my like terms, it's going to be x squared minus 8x plus 15. And isn't that the problem that we started out with? It sure is. So I'm done. So that's the factored format of my polynomial. And I'm done. Okay? But look what happens when a is not 1. Okay? Things change up a little bit. So let's do this one in green so we make sure it stands out differently to the previous problem. So let's do a, b, and c. A is 2, right there. B is negative 7. And c is my constant, negative 4. So the questioning technique here is going to change, okay? You're no longer going to do two numbers that multiply to be c, and but you are going to retain the two numbers that add to be b. That's not going to change. What's going to change here is that instead of c, it's going to be a times c. So AC. Some people call this the AC method. So I'm going to write this here. Some people call this the AC method of factoring. AC method of factoring. All right. So what is my AC? Well, my A times my C, 2 times negative 4 would be negative 8. And my B is negative 7. So you're still going to ask yourself what two numbers multiply to be negative 8 that add to be negative 7. When you have numbers that are 1 unit away from each other, just know more than likely one of the numbers is going to be a 1. So 1 times 8, but I need it to be negative, so I'm going to make this one the negative 1. So 1 times negative 8 is negative 8. 1 plus negative 8 is negative 7. So here's where it's different, okay? You're not going to do this and put an x, and put the numbers +1 and -8. Because look right off the bat, if I go x times x, I don't have a 2x squared. Okay, so you don't do that when a is not 1. What you're going to do is the following. You bring down the 2x squared of your original problem. So this comes down, okay? The -7x, I'm going to highlight it. The -7x is going to be rewritten as this right here. Okay, that's what it's going to be rewritten as. So 2x squared, -7 is going to be a +1x and negative, or I could just put minus 1x minus 8x minus 4. Okay, so this 1x and -8x came from that yellow. Okay, so I'm going to purposely put it yellow here too, so you know that that's where it all came up. So if you combine like terms, 1 minus 8x, notice that that's going to be -7. Okay, all right, so this -4 comes down, so this 4 comes down. So the first and the last term come down. So notice what you have here. Notice you have 4 terms. Okay, and what you're going to do is called factoring by grouping. Factoring by grouping. So you are going to split this up into 2 and 2, right? If you have 4 terms, you're going to split it up, 2 on one side, 2 on the other side. So I'm drawing a vertically double line just to split them up. All right, so do the GCF on either side. What is the greatest common factor between 2x squared and 1x? Well, it's just going to be an x, a 1x. So I'm going to put an x, open parentheses, 2x squared divided by x is a 2x, 1x divided by x is a 1. Okay, so +1. Close parentheses. Now I'm going to do it on the other side. What's the GCF between -8 and -4? It's going to be a 4. But since my -8 is negative, I'm going to put -4. Okay, open parentheses. X, sorry, not x, 2x, -8x divided by -4 is 2x. -4 divided by 4 is +1. Okay, so whatever the sign of your first term is, make sure you always use that sign. So what I'm saying is, let me make it a point here. These first 2 terms right here, you see these first 2 terms right here? The first term was a 2x squared, right? So this 2x squared, why is it doing that? I'm trying to get that away. Okay, now it's not cooperating. I'm so sorry. Hold on a second. Okay, here we go. So, oh my gosh, it went back to doing it what it did. Okay, hold on. Ugh, this is so aggravating. Okay, so I'm not going to use that again. So what I'm saying is this 2x squared right here was positive, so this was a positive unit. This here was a negative, so this here was a negative. So the first term of the pair, whatever that sign is, that's the sign of your GCF, okay? So that's all I wanted to try and tell you before the technical glitches. So anyway, once you've done that, you are going to make sure that what's inside the parentheses match. So see, this and this, they have to end up being identical. And if they are, you are now ready to put 2 sets of parentheses and insert the information. The GCF from each side of that vertical line gets put in one parentheses, and what was the same gets put into the other parentheses. And now you have factored it out. And if you wanted to check, you can go ahead and do the multiplication of all of this, and you would notice that you end up with 2x squared minus 7x minus 4. Okay? Factoring by grouping. So here's an example. You would divide, let me put the dividing line in a different spot actually. Hold on there. Let's put the dividing line right here. Okay? So 2x cubed minus 3x squared. So 2x cubed is positive. So I know my GCF has to be positive. So the GCF here is an x squared. So I'm going to put 2x minus 3. Okay. And the GCF here has to be positive because that number is positive. The highest number that goes into both of those is going to be a 9. So I'm going to be positive 9. And this is 2x minus 3. So notice again, those are matching. So I am able to put x squared plus 9 and 2x minus 3 in the other parentheses. Now this is what I want to make sure that you notice is going to happen in Delta Math a couple of times. When you guys are asked to find zeros or x-intercepts or roots, you know that you take your factors and you set it equal to 0 and solve, okay? So like 2x minus 3 equals 0. I would add 3 on both sides. I would end up with 2x equals 3. Divide 2. And I end up with x equals 3 over 2. Okay? So I'm going to box that in. That's a real solution, but look what happens on this one. When I subtract 9 on both sides, I'm going to get x squared equals to negative 9. That's not such a thing. If I multiply a positive number times another positive number, I'll always get a positive number. And if I multiply a negative times another negative, I'm going to still get a positive number. And according to this, if I do x squared, I'm going to get a negative number. That's impossible, okay? That's going to be a non-real solution. Another way you can think of it too is if I square rooted both sides, okay? If I square rooted this side and I square rooted this side, you're going to get x equals plus minus, but the square root of 9 is actually what we say 3i. It's a complex number. So these are non-real. So you will not put these answers in Delta Math, okay? But if, for instance, you had ended up with x squared equals to 9, and you square root both sides, then x is going to be plus or minus 3. In other words, 3 is an answer, negative 3 is an answer. Same thing like this. X squared equals, how about if it was a number that cannot be square rooted? Let's say it was x squared equals to 6, okay? And if I square root and square root, you'll get x equals positive, negative. The square root of 6 is a decimal number, so just leave it as square root of 6. So you would actually write this answer in Delta Math, okay? So I wanted to bring that to your attention, okay? Okay, so let me move back. Well, I guess I could have left that part there. Actually, let's do that. Let me go back, leave that there just in case you needed to look at it. This part I will erase. Okay. This problem, that example, I'm going to let you guys practice on your own, as well as, on this one, I do want to bring you a heads up. Make sure to do your GCF first, okay? Look at these problems. Look at the negative 3, the 18, and the negative 15. Okay, what is the GCF going to be? Very good. GCF is going to be a 3, but make sure it is negative because the first term was negative. So negative 3. So pull that negative 3 out before you continue factoring, okay? Same thing with this one here on this next example. Make sure you do your GCF, all right? All right, let's go down here to the last two problems. So, second to last problem is kind of worked out already for us, and that was on purpose because we're going to work out the last one together. So, you will either get a sentence or a table format for these problems. So, what is given to us in this problem? So, they said the function f of x is a quadratic function. So, quadratic function means that the degree has to be 2. They told us that the zeros are -5 and 2. And they told us the y-intercept is 10. So let's write out what that information means. Okay? So if our our quadratic function is, our function's a quadratic, we know that the degree has to be a 2. So the highest power is going to be a 2. The zeros are -5 and -2. So what does that mean? Well, if you look over here to the left, because I know the zeros are -5 and 2, I can write the factors as x plus 5 and x minus 2, which is what I did. So -5 is written as x plus 5, 2 is written as x minus 2. Now, you are always going to put this a, because this is the coefficient you are looking for the function. I know I'm multiplying these two factors, but I don't know what the coefficient's going to be. So that's what you're going to look for. Now, how do you look for it? Well, they gave us the y-intercept, okay? The y-intercept is 10, and we know that y-intercepts mean that we have to always let x be a 0, because remember, it's written as 0, comma, y for y-intercept. So if they gave us 10 to be our y-intercept, our coordinates are 0, comma 10. So 0 is my x and 10 is my y. So what I did is the f of x was replaced with a 10 because f of x is y, right? And every x was replaced with a 0. Okay, so you substitute. 0 plus 5 is a 5. 0 minus 2 is a -2, and when you multiply 5 times -2, you get -10. And then you had to divide both sides by -10 to isolate your a, to get this to cancel, and a is -1. So when you got that answer, you come back here, and now you're going to replace the a that you were first looking for with -1, because now you know what it is. Remember, here at the beginning, this was my a. I didn't know what it is, but now I do. So now that I substituted it, I need to start multiplying because they wanted the final answer in standard form, not factored form. So if it was factored form, I would stop here, but I want standard form. So what you did first was you multiplied this times this, that's x squared. This times this is -2x. This times this, positive 5x. This times this, -10. So when I put these together, that becomes 3x. So this is where they got this part right here from. X squared minus 3x, plus 3x minus 10. And then you can't forget that -1, which came down, and it needs to multiply to everything. And that's how they switched signs. The positive 3x became negative, and the -10 became positive. And this now is your final answer. And notice there are no parentheses, so it is indeed in standard form. Okay? So how do we do this when it's in tabular form? Well, here we go. We know it's a cubic function. So cubic function means our answer has to have a degree of 3. And by the way, up here, notice here, this was the degree of 2. So we know we're good. Okay? So this has to be a degree of 3. And we know from the previous problem that we need to find our zeros, or our x-intercepts, however you want to call it, our zeros, if any, and our y-intercept. Okay? Now, what you guys have to remember with zeros is that, I'm going to put this in red here at the side, it means that your x not your x. Zeros are x-intercepts, my bad. Your, why is that not erasing? Okay, here we go. Your x, oh my gosh, I did it again. Yeah. Okay, ignore me. Your zeros mean that your y is 0, okay? And y-intercept says that your x is 0, okay? So, when I'm looking for my zeros, which one has a y of 0? So, this here has a y of 0, this here has a y of 0, and this here has a y of 0, because f of x is y, okay? So my zeros or my x-intercepts were -3, comma, 3, comma, and 4. What is my y-intercept? Well, my y-intercept is when x is 0. And my y-intercept is, I'll put a cloud, is this one. Because here my x was 0. So y-intercept is 0, comma, 36. Okay? So we are going to write our formula. F of x equals the a, which we're looking for, and now we write the factors. The -3 becomes x positive 3. The root 3 becomes x minus 3. The root 4 becomes x minus 4. Notice how I switch signs on all of them. Now, let's substitute the y-intercept. The f of x is going to be 36 equals a, and my x is the 0 from the y-intercept. 0 plus 3, 0 minus 3, and 0 minus 4. So I plugged in my y-intercept, and now it's just simplifying. 36 equals a, 3, -3, and -4. So what's 3 times -3? Well, 3 times -3 is a -9. And then a -9 times -4 is a 36. So 36 equals a times 36, or 36a. Now I have to solve for a, so I've got to divide by 36 on both sides. And so the a is a 1. Now, I'm not done, okay? I'm going to take that and put it back into my original equation. This one right here, the one I'm putting arrows by, okay? So, f of x equals the a I found to be a 1 times x plus 3, x minus 3, and x minus 4. This is my factored form, but I need it to go into standard form, okay? So that means I've got to multiply. So let's multiply. X plus 3 times x minus 3. Well, that's difference of squares, but if you didn't realize it, you can just multiply. X squared, -3x, positive 3x, minus 9, and -3x plus a 3x makes a 0. So you're left with x squared minus 9. But then I bring down that x minus 4. Whoops. The x minus 4 that was standing alone waiting. Okay. And the 1, by the way, here is negligible because 1 times anything is just itself. And so now I have to multiply again. X squared times x. X squared times -4. -9 times x. And -9 times -4. And we look to see if any terms can be combined, and none of them can be combined. So this is the standard form of our answer. And we're done. Thanks so much for watching.